Now we are going to use our conjectures to decide whether the triangles are congruent. If they are congruent, we're going to write a congruence statement. And we're going to provide the conjectures that show that they are congruent. So let's just start with number one. Number one tells us that line segment FE is congruent to line segment GH. And it also tells us that angle EFH is congruent to GHF. Now we also have to remind ourselves of that reflexive property that side FH has to be congruent to itself. Now I'm going to put 2 tick marks there since we're already using the 1 tick mark to show that FE is congruent to GH. The reason why I don't have another set of 2 tick marks is because we're just using it to show that FH is congruent to itself, because that side is shared between both triangles. So now let's take a look. What do we have here? We have side, angle, side. 1 tick mark, angle, 2 tick marks. Let's make sure it matches over here. 1 tick mark, angle, 2 tick marks. So it does match. So we have side, angle, side congruence, and we have to write our postulate. So remember, our first triangle we can name however we want. So I'm going to go 1 tick mark, angle, 2 tick marks. So angle triangle GHF is congruent to triangle EFH. Okay, so for the next problem, we're told that angle A is congruent to angle Q. Angle B is congruent to angle R. And AC is congruent to QS. So we have 2 angles and a side. The sides that are congruent are not sandwiched between the angles that are congruent. So that means we have angle side congruence here. And we can always go back and check. So angle side. And then we want to put our congruence conjecture. So we can go any order we want for the first triangle. So I can do triangle ABC. Is congruent to, so I went from the angle with 1 mark to the angle with 2 marks to the angle with no marks. So I got to go 1 to 2 to none. So triangle QRS. For the third one, we're told that angle QPR, that's this angle right here, is congruent to triangle SRP. And angle QRP, right here, is congruent to angle SPR. So we have 2 pairs of congruent angles. Now, angles alone are not enough. But remember, that reflexive property, that's something that's just our responsibility to always remember, that something has to be congruent to itself. So PR has to be congruent to itself. So here we do have the side that's sandwiched in the middle, of the pairs of congruent angles. So we have angle, side, angle congruence. And then if we go none to 1 to 2, we would do triangle QPR is congruent to triangle none to 1 to 2, SRP. And we could have done any order. We just had to match it in the second triangle. Okay, HK is congruent to LJ, and HJ is congruent to KL. Then we also have to recognize that KJ has to be congruent to itself because it's shared between both triangles. So that means we have all three sides that we know are congruent. So that one's easy, side, side, side congruence. And then we just have to match the order. So triangle, we can go any order we want for the first one. So I'm going to do KHJ. So I went down the 1 tick mark, then down the 2 tick marks. So I'm going to do triangle JLK. Okay, for number 5, AD is congruent to BC, and angle ABD is congruent to angle CDB. And then we know that sides that are shared have to be congruent to themselves. Now let's take a look here. We have two sides and an angle. Two sides and an angle. Let's look at our conjectures. If we have two sides and an angle, the only way that works is if it's side, angle, side. If the angle is sandwiched between the pairs of congruent sides. But when we look at this, the congruent angle is not sandwiched between. So sandwiched between would be that angle up there. And that's not the ones that are marked congruent. So this, all we know here is angle side, side. So not congruent. Or at the very least, not enough information to prove congruence. We cannot prove congruence on this one. Okay, we're told on number 6 that OS bisects PR. So that tells us that PQ and QR are congruent to one another. And we're also told that OP and RS are parallel to one another. So if they're parallel to one another, then that means we have alternate interior angles here. We also have alternate interior angles here. And let's not forget, vertical angles are always congruent to one another. So we know that all of our angles are congruent, which angles alone are not enough to prove that triangles are congruent. But since we also have a pair of sides that are congruent, we actually have two different conjectures that we could use for this one. So we could do angle, side, angle. Or we could do angle, angle, side, because we know all of the angles. And both of those are allowed conjectures, and we could use either one. It's up to us. It doesn't matter which one we use. So let's name it. So if we name it triangle OPQ, so I went from 2 marks in the angle to 1 mark to 3 marks. I got to go from 2 to 1 to 3. This is an S over here. This is an R right here. So triangle SRQ. For the next problem, we know that KN is parallel to LM. So that's telling us that this angle matches this angle. Let's not forget these letters. We already know that this side has to be congruent to itself. And then we're being told that NM is congruent to KL. So we have two sides at an angle, and the angle that we have is sandwiched between the sides. So we have side, angle, side, side, angle, side. So I went down the parallel side, then down the 1 tick mark side. So I've got to go LMK. All right, for number 8, VW is perpendicular to TV. So that tells me that there's a right angle right here. TU is perpendicular to TV. So that tells me there's a right angle right here. We know that a side has to match itself. And then we're also told that TW is congruent to UV. So in this case, we have right triangles. So we're going to always check hypotenuse leg when we have right triangles. And we do, in fact, have a shared leg. So we know that that's congruent to itself. And then we also are told that the hypotenuse are congruent to one another. So triangle, we can start the first one however we want. WVT. So I've got to go from I've got to go triangle UTV. There we go. Angle E and angle R are right angles. So we're not just marking them congruent, we're going to mark them as right angles. TE is congruent to HR. And EX is congruent to RF. Now, these are right triangles, and I said when you have a right triangle, the first thing you're going to check is hypotenuse leg. Well, we check hypotenuse leg, and we realize that we don't have hypotenuse leg here, at least not labeled, because we're not told that the hypotenuses are congruent to one another. We're only told that the two legs are congruent to one another, and we're told about the right angles. So we don't technically have hypotenuse leg here, but we do have side, angle, side, side, angle, side. And we're allowed to use side, angle, side. We can use any of the other conjectures on right triangles. It's just that hypotenuse leg can only be used on right triangles. So triangle TEX is congruent to triangle. See, I went down the 1 tick mark side, then the 2 tick mark side. So HRF. PQ bisects SPT. So that tells me that this angle right here matches this angle right here. We know that PQ has to be congruent to itself. And we're also told that SP is congruent to TP. So we have side, angle, side again. Side, angle, side. So I went up the 1 tick mark side, then down the 2 tick mark side. So for the second triangle, I'm going to go Q, P, T. X is the midpoint of VY. So I'm going to mark that those parts are congruent. XW and YZ are parallel to one another, so if they're parallel to one another, that means we get corresponding angles here. Corresponding angles are congruent. And then we're told that angle YXZ is congruent to angle XVW. So we have angle, side, angle. Angle, side, angle is completely allowed. What's not allowed is ASS. So I'm going to go no tick marks to 1 to 2. So triangle WXV is congruent to triangle ZYX. Okay, WX is parallel to YZ. So that tells us that we have this transversal here, which means we're going to get alternate interior angles here that are congruent to one another. And then we're also told that angle W and angle Z are right angles. And we know that the side has to be congruent to itself. So remember, this was Y down here, and this was X up here. So YX has to be congruent to itself. So we have two angles that match, two pairs of angles that match. Because we've got this one matching this one. And then we've also got this one matching this one. And we've got a side. We also, because we know that Z and W are both right angles, we also know that those lines have to be parallel to one another as well. I'm going to go ahead and do angle, angle, side. You could also do ASA on this one because you have some additional information with those 90-degree angles there, forcing those other pairs of sides to be parallel to one another. So that would mean that we also know that those angles, so there's 180 degrees in a triangle, we would also know that these angles would have to match as well. So we could also do angle, side, angle. So triangle WXY is congruent to triangle ZYX. All right, are there any orders of sides and angles that do not prove triangles are congruent? Yes, there are. If you only have one angle and two sides, it has to be, the angle has to be in the middle. So SAS is fine, but you cannot have ASS or SSA. And then angle is similarity only. So now we're going to circle which methods could be used to prove two triangles are congruent. So if we prove that all three angles are congruent, that would be angle, angle, angle. Well, that doesn't work. Angles only prove similarity, not congruence. Prove that two angles and their included side are congruent. Included sides, so the S is in the middle. That is allowed, so that one's correct. Prove that all three corresponding sides are congruent, so that's side, side, side. That absolutely works. Prove two corresponding sides and one pair of corresponding angles are congruent. So for this one, if we have two corresponding sides and one pair of corresponding angles, that could be written as SSA, ASS, or SAS. This one works. These two do not. So that's not enough information to say that we could use this. All right, now let's get down to the last few problems. Which of the following is true about the following triangles? So we know that we have parallel lines. So if we have parallel lines cut by a transversal, we know that these angles are corresponding, so we know that they match. We know that we've got another transversal over here. These angles are corresponding, so they match. And then this angle is shared, so it has to match itself. So we know that all of the angles match, but we don't have any information about any sides. And to prove congruence, we have to know something about at least one side. That's the minimum amount of side information that we can get to prove congruence. So we have enough information here to prove similarity because we know that all of the angles match. And we only need angle, angle in order to prove similarity. But we just don't have enough information to prove congruence. And then number two, which of the following is true about the following triangles? So we have a 6 side, a 20-degree angle, and an 8 side. 6 side, a 20-degree angle, and an 8 side. So we have pair of congruent sides, another pair of congruent sides, and the angles between them are congruent. So that's side, angle, side. Congruence. Now, this one's a little tricky because there's no such thing as congruent but not similar. If they're congruent, they are similar. It's just that their ratio to one another is 1-to-1. Okay, so B is not a real option. It's not a viable option. You can have triangles that are not similar or congruent. You can have triangles that are similar but not congruent. So where they're the same shape, but one of them is bigger than the other one. They have a proportion between them. Or you can have congruent triangles. Congruent triangles are similar to one another. They just have a scale factor of 1-to-1.